Live. So today's date is 4/26/18. Common Core Standard really is going to be the Law of Cosines. Okay, and in our reading we saw the formula, so I was kind enough to write it down for you. Look at that. How nice of me to type it up for you. There it is. So we have the opposite squared is equal to the adjacent squared plus adjacent squared minus 2 times the adjacent times the adjacent times the cosine of theta, okay? And again, you do not have a pair of opposites. In fact, if I look at example 1, we don't have a pair of opposites, right? So the law of sines won't work, so we have to shift to the law of cosines. But we do have side, angle, side, right? So if we do have side, angle, side, we can find the opposite side. So this would be, x would be my opposite side, right? That'd make my 12 be my adjacent, and my 10 be my other adjacent, right? So I'm just going to set up my formula. Slide over. It's a long formula, but I can handle that. So we'll go opposite squared, which is x squared, equals adjacent squared, which is my 12 squared, plus my adjacent squared, which is my 10 squared, minus 2 times my adjacent, which is my 12, times my other adjacent, which is my 10, times the cosine of my angle, which is 58 degrees. Okay, so I'm just going to put that in my calculator, and I should be able to get an answer. Put it over here. Okay, put that there, and I can see it. So clear that. So I'm just going to go 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 58, and I get 116, but that's x squared equals 116.8, right? So we'll just take the square root of that. So square root, and I get the opposite side to be, well, let's see, the square root of 116.8, and I can answer about 10.8. Does that answer make sense? It does to me. I mean, if this is 12 and that's 10, that could be 10.8, okay? So you should always go back and say, does my answer make sense? And that does. 10.8 makes sense, okay? Now, if we needed to solve the rest of the triangle, let's go down to number 2, and let's take the law of cosines, and let's take a look at finishing up the triangle. So what do I mean by finishing up the triangle? That means we're going to have to find angle A and angle T, okay? But first of all, there is not a pair of opposites, right? There's not. But we do have side, angle, side. So I do have side, angle, side. And because I do have side, angle, side, yeah, let's use the law of cosines again, all right? So same formula. Let's let little f be my opposite, okay? So we're going to set it up. Opposite squared, little f squared, right? That's my opposite side, is equal to my adjacent side, which is my 7 squared, plus my other adjacent side, which is my 8 squared, minus my 2, because that's in the formula, times my adjacent side, which is my 7, times my other adjacent side, which is my 8, times the cosine of 63. And I'm just going to use my calculator to get that, right? So I'm just clear that. I'm just going to hit my calculator. 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine is 63, and I get an answer, but that is f squared, right? That's f squared is equal to my 62.15. So I'll take the square root, I'll take the square root of that 62.15, and I get an answer about 7.88. Little f 7.88. Okay, so now since I have to solve the rest of this triangle, I'm going to actually put that number in there, okay? So I'll put my 7.88 there. Okay, so I'll go 7.88, and I'll come back and use it. Now, at this point, you could do a couple of things, but now all of a sudden, I have a pair of opposites, which makes it easier, because this is a long formula, isn't it? But if I have my opposites, I can shift formulas and go from the law of cosines. Let's go to law of sines, right? Because law of sines is a lot easier. Little itty-bitty formulas, law of sines. So let's shift. We have our opposites. So I could at this point either find angle T or angle A. It doesn't matter. Ashley, what do you want? A or T? T it is. So Ashley picked T. So let's find angle T. So we'll set up our opposites, right? So we'll say, all right, sine of angle T over its opposite side, 7, should equal the sine of 63 over its opposite side, which is 7.88, right? Okay, cross multiply, so I'll basically just bring the 7 up here, right? So I'll rewrite this as sine T equals 7 times the sine of 63 over 7.88. I'll just do that in my calculator real quickly. So I'll put the calculator over here, clear that. 7 times the sine of 63 divided by 7.88. And I get a decimal because I need to sine inverse that, right? I'm going to make sure I sine inverse that 0.79, blah, 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 blah. So I like to use the answer button. So I go sine inverse, and I like the answer button because then I don't have to type that decimal anymore, right? And I get 52.3. Does that make sense? That's an angle, right? Yeah, it does. It makes sense to me. So angle T is about 52.3 degrees. Okay, so I'm going to put that in my drawing now. So it's about 52. So I'll put that up there, 52.3. And then finally, angle T, whoops, I put that in the wrong place. 52.3, I did, I put that in the wrong place. So finally, angle A, which I just messed up on. But how do you find angle A? Well, that should be easy, right? Geometry, right? 180 degrees, you guys agree? So let's just go straight to angle A is equal to 180 degrees minus the sum of 63 and 52.3. I'm just going to use my calculator on that one. 180 minus 63 plus my 52.3, and I get an answer of 64.7. 64.7 degrees. Okay, thumbs up. Thumbs up. Law of cosines is really actually not difficult. It's just long. And as long as we have a calculator, we can put it in, okay? All right, turn the page. Now, if, take a look at example 3, you don't have a pair of opposites, right? In fact, you don't have an angle at all. You have side, 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 don't you? So what I did, in fact, let's highlight this. Let's highlight this, okay? Let's highlight this. And then I'm going to flip the page, okay? See this formula? I took this formula and just solved for cosine, right? So I subtracted that, and divided it by a -2 adjacent, so I solve for cosine. And when you take this formula, if you solve for cosine, you do the math, guess what you get? That. So this is really the law of cosines. It's just been rewritten in a different form. Okay, so it's been rewritten in a form so that we can find the angle. So if you need to find the angle, you want to use that formula. Okay. So let's see how it works. So the first thing you have to do is figure out which angle you want to choose. So on this one, here's theta. So once this is my angle, I'm gonna label or name my sides. These two would be my adjacents, right? Because they're next to it. And the 18 is my opposite, right? So if I'm going to theta, that's my opposite, and these are my two adjacents. There's no hypotenuse, so there's no Pythagorean theorem, right? It's not a right triangle. So let's set up the formula. So it goes cosine of theta. So I'm going to write cosine of theta equals, let's see, adjacent, which is 10 squared, plus adjacent, which is 18 squared.
17.
Oops, 17, my bad. Thank you, guys. Oh, yeah, 17. Minus 18 squared, all divided by 2 times my adjacent, which is 10, times my other adjacent, which is 17. Now, in your calculator, everybody, if you're not going to listen today, listen right now. Make sure you have parentheses, because in your calculator, if you don't use parentheses, you won't get the entire top divided by the entire bottom. That makes sense, right? So I have to have these parentheses in my calculator, okay? So if I do this on my calculator, I'm going to go clear. And I'm going to go here, I'm going to go to parentheses. Yeah. Otherwise, yeah, there you go, okay. So I'm going to go parentheses. Got to have parentheses. It's very important. You go parentheses 10 squared plus 17 squared minus 18 squared parentheses. You have to have the parentheses. So you have the entire top divided by parentheses. You have to have the parentheses, so you have the entire bottom, okay? 2 times 10 times 17 parentheses. Enter. And I get a decimal. That makes sense to me. The decimal makes sense because we have cosine of theta equals 0.19117, blah, blah, blah. And we all know if we want to find an angle, we've got to do the cosine inverse, right? So I'm going to do my cosine inverse of my 0.19117. Or I'm just going to use my answer button, right? I'm just going to go second cosine of answer, and I get about a 79.97, or how about 79 degrees, okay? Or theta's about 79 degrees, okay? Not too hard, is it? You just have to put things in.
Does it matter what mode you're in?
Yes.
You have to be in reading?
Yes, no, you have to be in degree. So David has a really good question. We haven't talked about the mode yet, because in next week we're going to talk the mode specifically, but if you go to mode, there are two ways to describe angles. Radians, which we don't know what those are yet, and degrees. We're going to learn about radians next week, okay? Cosine inverse. Can I see what you got? Were you in radians before?
Nope, I was in degree. Wait, what is happening?
Try it again. I didn't see it. Okay, I tried to. Okay. Hopefully you get the same answer. Okay. All right. Now D. Let's take a look at D. Now one of the things to remember is this, and you don't know this yet, but I'm going to tell you. The law of sines. Are you listening? Will never give you an angle over 90. The law of sines will never ever, and we're going to learn this next week, but the law of sines will never give you an angle over 90, but cosine will. So when I take a look at this problem, the first thing I do is I could find any three angles, but find the obtuse angle first, okay? Because the law of cosines will get an obtuse angle. So let's find, so law of cosines will find obtuse angles. And you just have to believe me on this. We're going to learn this next week, okay? So let's go for angle D first, okay? So if we want to find angle D, then I know that the 8 is an adjacent, right? And I know the 6 is an adjacent, and I know the 12 is my opposite, right? If I picked a different angle, we'd have different opposites, different adjacents, okay? But if you have an obtuse angle, always use the law of cosines. Law of sines. In fact, we saw that in our bad triangle. Yes, remember that? We couldn't get that obtuse angle. Did we remember how we had to get the obtuse angle by subtracting from 180? Okay, so let's set this up. I'm going to go cosine of D equals 6 squared plus 8 squared minus 12 squared. Right? Oh, sorry, Katie, thank you. So I've got my adjacent squared plus my adjacent squared minus my opposite squared over 2 times my 6 times my 8. I'm going to make sure that I have parentheses. You get it right this time, David? Okay, parentheses, right? Got to have parentheses because I need, in my calculator, make sure I divide the top by the bottom. Okay, clear. So then if I go parentheses, 6 squared plus 8 squared minus 12 squared, parentheses divided by parentheses, 2 times 6 times 8 parentheses. I get a decimal, but that kind of, I expected a decimal, didn't I? Because I'm going to go cosine inverse of that answer, and I get an obtuse angle, 117 degrees. To me, that makes sense. It really does. We're going to learn more of why that makes sense next week, okay? So then, I get angle D. Angle D is equal to about 117.3 degrees. Okay, so I'll put that in there. Now, if I have to solve the rest of this triangle, I'm going to go straight to the law of sines because it's easier, right? So if I have a pair of opposites, I like the law of sines, right? So I'm just going to set up either to find angle G or angle I. Stephanie, when you put that phone away, will you tell me which one you want to do? Do you want to do G or I? Which one do you like, Steph? Give me one or the other. You could pick G or I. I it is. So Stephanie picked I, right? So I got my opposite. So I'm going to go sine of I over 6, right? Law of sines equals sine of 117.3 over 12. So law of sines can use an obtuse angle, just can't find one, okay? Multiply up the 6, right? Multiply the 6 up there. I'll use my calculator. So scoot that over so you can see it. 6 times the sine, 117.3. Close my parentheses, divided by 12, and I get a decimal. Kind of anticipate that, right? Because we're looking for the angle, right? So we've got a sine inverse that because we're looking for an angle, and I get about a 26.4 degree angle. Okay, so angle I is about a 26.4. So then finally for angle G, we'll go 180 minus the sum of the two angles, right? 26.4 plus 117.3. Okay, and I'll just do that in my calculator, right? 180 minus parentheses, 26 plus 117.3, and I get about 36.7 degrees. Okay, now, number 5. Find the area of the triangle above. Now, there's two ways to do it. Let's do Heron's formula. Normally, that's why I don't remember Heron's formula very often, because once I have an angle, I can just use what we did on our warm-up. Remember how we did our warm-up? Where we did the 1/2 adjacent times adjacent. Much easier, much faster. But let's use Heron's formula, okay? Let's use Heron's formula. Heron's formula. So first of all, the perimeter. S is a semi-perimeter, which is going to be 6 plus 8 plus 12 divided by 2. Let's see, that is going to be a 26 divided by 2 is a 13, right? And then the formula says area is equal to big square root of S, which is 13, times S minus A, which is 13 minus 6, times a 13 minus an 8, times a 13 minus a 12. And I just got to put that big ugly thing in my calculator, right? Now here. Alright, I'm going to do it in 2 steps so I don't mess up. 13 times 7 times 5 times 1, square root that answer. Boom. About 21.33. So I did that. Did a whole bunch in my head, right? Because we're smart, right? So 21.33. Okay, now, girls, you got to stay in today. You can't go outside.